What's up, everyone? Today we are going to talk about graphing quadratic functions. We are building up to the first of three forms that we are going to study from graphing quadratic functions from. There's three main ways we write quadratic functions, and each one gives us a little bit of a different view into some of the key features of the quadratic. So today we are going to look at graphing when you have something of this form, ax squared. So a quadratic function, a little bit of vocab to get us started, is a function that can be written in this form, ax squared plus bx plus c, where a is not 0. Because if a were 0, what happens? Well, that x squared term goes away and you're left with bx plus c. That is, of course, a linear function. The graph of a quadratic function is a U-shaped curve known as a parabola. Alright, so a parabola is going to be U-shaped, so it's going to look like this. Alright, so this is where that a little bit of heavy lifting on your end comes into play. So notice I have these tables down here. Oh, I forgot I have this cool laser pointer I can be using. These tables down here. You're going to graph f of x and g of x, so just the first two, using the tables that I've provided for you. So I have given you the x's, so how do you find the outputs? That's right, you're just going to plug them in. So you're going to plug in for x, and whatever pops out is your y coordinates right here. And then these make ordered pairs that you'll then plot over here. Got it? All right, go ahead and fill this up. Then you're going to have to describe and answer a couple of questions here. So go ahead, you can complete this whole first page without me. Can you believe that? All right. So let's say we filled these out here. I filled out this first one and I got 4, 1, 0, 1, 4 as my y coordinates. And when I graphed it, it looked something like this. All right, so that was f of x, our original. Okay, the next one, when I graphed that one, I remember when I plugged these things in, this one into 3x squared. And so order of operations tells me that thing, I square my x first and then multiply it by 3. So I got out 12, 3, 0, 3, and 12. So these went like off my graph at 2 and -2. Okay, so we're just going to remember that it's really, really, really tall. At -1, we went up 3, 0, 3. So this one looked something like this. And so we call that g of x. And so this part here, right, your answers are going to vary, of course. But hopefully you said something along the lines of they both open up. They're still both U-shaped. Maybe you said something along the lines of g of x is narrower than f of x. I always say that we're body positive when we talk about graphs. We don't say like skinny or fat. We're going to say narrower or wider. All right. So then, based on that, we wanted to say, well, what do you think is going to happen in h of x here? If we do 1/3 x squared, what's going to happen? All right. Well, if we do that, we ended up with 4/3, which is about 1.3. 1/3, 0, 1/3, and 4/3. I'm leaving it like this for a reason right now. So if I were to graph this at -2, I went up 1 and a little bit more. -1, I went up 1/3. 0 was still at 0. Then I went at 1, up 1/3, and at 2, up 1 and 1/3. Like so. So you can see that this one here is narrower. This one is wider. Okay. So again, right, maybe that's what you predicted. But maybe it's not maybe, right? You predicted something else, and that's okay because it's just a prediction. All right, and so then were they correct, right? Again, you're going to because it depends on what you guessed for number 3. All right, so what do we notice kind of going on here? Well, if I thought of 12 as 4 times 3, or I thought of 1 as 1 times 3, do you see kind of how a pattern forming in these tables here? Well, so whatever happens with our A, let's draw ourselves a little box here. Whatever happens with A affects our y coordinates. Did you notice that? So when A was bigger than 1, we noticed that, and we're talking about a positive number, so maybe we'll do absolute value. When A was bigger than 1, what happened here? Well, our y values grew, okay? So we're going to call that a vertical stretch, or you may hear it called a dilation. By radius. And so then what happened when A was small? So between, again, I'll use absolute value, when it's between 1, it was a vertical shrink by A, that same A. Or you might hear this called a compression. All right. This right here, this blue one, this is the parent function, which means that it's the most boring, the most plain Jane version of a quadratic that we can have. Remember, this was its graph here. And so every function is going to default to that. And I want to show you a little pattern it follows. So from my vertex, it always goes over 1, up 1. Then again from the vertex, over 2, up 4. And why does that happen? Well, whatever horizontal distance I'm traveling, it squares that. And that's how high I go. If I were to plot more points, you'd see that it would go over 3 and then up to 9 because it's the square of that horizontal distance. And so that's a good way if you don't want to memorize a table of values to remember this function. All right, so we are going to make a table of values for the rest of these and then go ahead and graph. So here, it's like we're taking, remember that 4, 1, 0, 1, 4, and then we're going to multiply it by a half, multiply 1 by 1/2, and so forth, right? That's how we are filling out our table. All right, so this is going to end up with 2, 1/2, 0, 1/2, 2. So I can just plot those points. Or if I think about my function, we know that it has that bottom, the vertical origin. And then when I went left 2, normally I would go up 4, but this one got chopped in half by that 1/2 up front. So instead, it's going to be half as tall. So it's going to go over 2, up 2. It's going to happen the other direction because it's symmetrical. So it went right 2, up 2. And then over 1, it's only going to go up half instead of 1. And it looks kind of like a V-ish right now. A common thing students do, well, they'll try to connect it and they'll make sharp edges, but remember, U-shaped curves, kind of curvy. And you don't draw it all in one line. You can make kind of like short little strokes. Obviously, you would connect them. It's hard to demonstrate. So you don't have to like do one perfect line like that. It's okay if you like connect 2 dots and then 2 more dots. Try to give yourself the best looking curve. All right. First one. Next one. Ooh, this is exciting because we haven't seen this negative out front before. So we don't know. We can predict that's probably going to change our y values to be negative, but we aren't entirely certain what's going to happen. So let's see. We are indeed going to end up with negative numbers. So -8, -2, 0, -2, -8. So we still see the symmetry there. We still see that it's going to have a U shape. So that's exciting. It still has dot at the origin here. But it looks like it's going left 2, down 8. And right 2, down 8. And then left 1, down 2. So it looks like our y values are just twice as high as they were before. And they're also negative. And see how I'm connecting kind of like 2 at a time. So I have a better looking graph there. All right, last one. 2/3 here. All right, so we're gonna end up with 8/3 when we plug this in. 2/3, 0, 2/3, and 8/3. If thinking in terms of fractions isn't so grand for you, totally get that. So you could always think about the decimal approximations. You could say like 2.7, 0.7, so on and so forth, if that helps you kind of visualize what's going on here better. All right. So over 2, up almost 3, but not quite. Over 1, up almost 1, but not quite. Oh no, my point disappeared. Sometimes I draw points and my Apple Pencil thinks that it is trying to scribble erase. All right, and then I'll connect these guys here. And there you have it. We've learned about the first part of our quadratic functions. Oh no, I deleted half my graph by accident again. All right. Oh man, why does that keep happening? This is just weird. All right. Hopefully it stays that time. And there